Hey, this is Mr. Hanson. I wanted to introduce the concept of function in this video, and I wanted to start off with something that you guys see every day at school. That's a soft drink machine, or maybe you see it at other places, but the idea is that soft drinks cost $1, and each time you order a soft drink, you get out one soft drink. So let's just do some ordered pairs here. Put one in, get one out. If I put $2 in the machine, I'd get out two soft drinks. If I put $3 in the machine, I'd get out three soft drinks. So this is a group order, and for each input we have exactly one output. What would happen? Oh, we call this a function, by the way. It's a grouping of ordered pairs that for every input there's exactly one output. What would happen if you put $1 into the machine and you got out two sodas? Well, you'd probably be jumping for joy, wouldn't you? That would be great. But then the predictability of this soda machine is gone, and so there is no longer a function. Still a relation to a group of ordered pairs, but it is no longer a function because when you put one in, you expect to get out one. If you put one in and get out two, then it just doesn't work. So this is now any grouping of ordered pairs, not a function. If I were to take this last one out here, it would be a function. Okay, let's take a look at another situation. Here's the weatherman chart, and maybe on Sunday it is going to be 65 degrees for a high, and then on Monday it'll be 70, and Tuesday it'll be 70, and Wednesday it'll be 65, and Thursday maybe it'll be 75, and then Friday maybe 80 degrees. Think about this. On Sunday we only have one high temperature. It is 65 degrees. If we had two high temperatures, it would be difficult to determine which high temperature to choose. So the input is Sunday, and the output is a high temperature of 65. Um, the input is Monday, and you have one high temperature of 70. Tuesday, you have one high temperature of 70. Wednesday, you have a high temperature of 65. Thursday, 75, and Friday, 80. Now, if I were to put a dot right here, there would really be an issue because now on Sunday, you couldn't really determine if the high temperature was 70 or 65. So that would make it not a function. But if I were to cross that one out, then it is a function there. So with the dot, it's just a relation, just any old grouping of ordered pairs. And without the dot, it is an actual function where you have one input for each output. Let's take a look at another one. I've got this equation here. An equation also represents a grouping of ordered pairs. You can put some numbers in, like let's put, and you can choose any numbers you want for x, but I choose simple ones. Negative 2 squared is, negative 2 times negative 2 is 4, plus 1 is 5. Negative 1 squared, negative 1 times negative 1 is 1, plus 1 is 2. 0 squared plus 1, that's 1. 1 squared again is 1, plus 1 is 2, and there you have it, 5. So the question is, we have five ordered pairs there. Does this make a function or not? Well, every time you put negative 2 in, you know you have to get out 5. If I put negative 2 in and got something different out, then that would be a problem. But it's not happening that way. Every time I put negative 2 in, I get out 5. So based on that ordered pair, it's a function. I put negative 1 in. The only thing you can get when you put negative 1 in right there, the only thing you can get is 2. So that also tells me so far it's a function. You put 0 in, same thing. You put 1 in, same thing. And finally you put 2 in, same thing. So this is a function for each input. For each one of these things here, there is exactly one output. Okay, I'm going to kind of turn this around. I'm going to go x squared equals, I'm sorry, let me try it again, y squared equals x this time. Okay, now let's think about some inputs and outputs we could use. Let's go x is 1, And so what number squared is 1? It's 1. What if x is negative 1? X is negative 1. Let's do this. Let me think this out. Get rid of that name. I'm going to put x is 1 in again. X is 1. Is there another value that if we put it in for y, right there, would make x 1? Think good and long about this. If you said y is negative 1, negative 1 times negative 1 is 1. So there you have it. Okay, can you tell that this is not going to be a function? Because if you put 1 in, you can expect to get 1 out. But here we're putting 1 in, getting negative 1 out. So y squared equals x is not a function, but y equals x squared plus 1 is a function. All right, let's take a look at this. Time in hours and distance in miles. This might be a family trip or something, and you could almost sketch this, and I think that's what we'll do. We're kind of sketch this on a y-axis, and so here's let's do this in a thinner marker. 1, 2, 3, 4, 5, 6, something like that. And so we start here. 0, 0, 160, 2, 100, 3, 150, 4, 230, 5, 230, and 6, 270, something like that. Okay, and of course between these hours you're going to go certain distances too, so you can kind of just connect the dots here for right now, something like that. And the question is this a function? Well, looking at the table, at 0 hours, you have 0 miles. There's no other thing you could put in there. If you put something else in there, let's do this in a different color. If you put something else, like at 0 hours, maybe 60 miles, it wouldn't make sense because it's either one or the other, but it can't be both. So this here is indeed a function. Now, some people get hung up on this part right here, and they kind of think of things backwards. For every input, there should be exactly one output. Well, 4, that's your input, there's exactly one output. And 5, there's exactly one output there too. So this part right here, that's still a function. One way to tell if something is a function is you can use something called the vertical line test. It's where you take a line, like that green line there, and you move it. So you move it across your graph. I'm just going to move it to the right there. So I'm going to put some arrows in and let me move it to the right. And as you move this vertical line to the right, your graph can only touch the line in one spot. If it touches in 2 spots, you know it's not a function. So this one, as you move it to the right, should pass the vertical line test. It's definitely a function. Okay, let's kind of wind things up here. Any grouping of ordered pairs, any old grouping of ordered pairs is called a relation. And that's pretty broad. That's kind of a broad idea there, so we have it in the biggest circle. Now, a more specific relation is a grouping of ordered pairs that gives you exactly one output for each input, and that's called a function. And we can take a look at relations using a graph or an equation. These are all ways to write ordered pairs. That's all we're doing. A table is another way to write ordered pairs, a list of ordered pairs. All of these ways here are ways to write ordered pairs. And we can determine if the grouping of ordered pairs is a special kind of relation, a function or not. If it's a function, for every input there is exactly one output. Hopefully this helped you understand the concept of function. Have a wonderful day. Take care.